Okay, let's make sure I get the clicker on. There we go. Okay. Hi, everyone. I'm Grant. I'll be doing your lecture today. So first, just to start out, you want to do what you did last time with Git. So you want to go to your working directory that you have your repository, add in the changes you've made, commit them, and then go ahead and fetch what's currently on the remote server, and then check out the lecture so that you're able to actually work through the notebook today that we'll be going through. I don't quite know how much time I should give you guys to do this, but give you just a few seconds. Okay. So once you're actually able to get the notebook that we'll be working with, it should be in the lecture 4 right here. And it's just going to be lecture 4.ipython notebook.
Hey, Grant, would you mind posting those again just for maybe like 30 seconds?
Sure. Okay.
Thanks so much.
Okay. Okay, so I launched a poll so we can see if everyone has gotten Git good yet. Okay, so we're getting around 2/3 of the people who have gotten everything updated so far. The 1/3 that hasn't, you can kind of do some debugging in the chat with the TAs, or if you go to, I believe you'll have links to the GitHub repository online. You could go there and save down the file, I believe. That might also just be a quick workaround if you need to get the Python notebook for today. But okay, I guess with that, maybe I'll just start. Okay, so welcome everyone. So we'll be working today with a bunch of different sequential data types. So these are going to be really important for your, and basically anything that you make in Python. There are going to be lists and dictionaries. We're actually not going to cover sets. We're going to cover lists, dictionaries, strings, and tuples. So, and then we're going to talk a little bit about assert statements, which you should be seeing in the assignments. They're being used to check your work. We'll talk a little bit about them to make you understand exactly what's happening under the hood. Yeah, so your assignment should already be uploaded to the OneDrive folder. If you don't, put on Stack Overflow. It should be there, or just talk to one of the TAs. Yeah, so post the steps again. So if you are in, yeah, Emily's got you. Okay. Okay, so before we begin, this is just something, this is an aside that might help you out when working with these Python notebooks. So if you're in Visual Studio Code and you have a Python notebook opened, there should be this toolbar up top. There's this grid icon here. If you click it, it's going to actually show you the current variables you have defined inside of your workbook. So you know how if we go into any kind of thing and we go, like variable equals to something or another, it's going to be instantiated, and then it's actually going to be printed up here. So this might be good for bug testing or making sure that you have things put like currently in your kind of workspace that you think are. So just make sure that you check that if you have any issues, and just know that this is a feature. It's actually a feature of VS Code. It's not something in kind of vanilla Jupyter Notebook. So it's a cool addition since we're using the software anyway. Okay, so let's just start talking about our first sequential data type. So we're first just going to talk about strings. So you all probably understand a little bit about strings already. A string is essentially, it's just made up of a bunch of different characters. And the interesting things is, let's do A, B, C, D, E, F. So if I have a string like this, we can access each individual character inside of the string. So we like to say that kind of strings are you can subset just a variable of a string in general. So let's make a new one for example purposes. Let's make it, my name is Grant. And the way that we can access characters inside that string, so let's go print string, is that we have our variable, which is string. We're going to open these brackets, so square brackets. I'm just going to call them brackets. And you just put in a number. So what the number is going to be is it's going to be the index of the letter that you actually, or the character rather, of the string that you want to access. So let's get the M here. You're just going to put in 0. And you'll get the M. So how indexing works in Python is that you're going to be starting from the digit 0, and you're going to go up by 1 for each and every entry inside of the string. So if I want to get the Y, it's going to be 1, and so on. Now, if I put in 2, as you guys can see, there is a space right there. This space is actually a character too. So if I want to get the N, it's not going to be 0, 1, 2, but instead 0, 1, 2, 3, just like that. So that's something to be aware of when you work with more complex strings or strings that are sentences in themselves. Okay. So, and this might be a little bit confusing if you come from maybe MATLAB or R, because those languages have the indexes for all their different things starting at 1, but most languages, including Python, start at 0, so that's something just to keep in mind. Okay, so let's just continue down. So we don't only, we can get single kind of characters or letters, but we can also access subsets. So we can access, for example, just the word name or the word is. So let's see how that works. If I want to get name, I'm going to first get the start index. So the start index for name is going to be just this N here. So that is going to be 0, 1, 2, 3. Okay. And then I'm going to grab the index. So wherever in this string the E is, plus 1. So this is a really important thing, that the character at the of the index is not included. So this is like if you have in math, you have that bracket and then the parenthesis. If you're familiar with that, you want to not put you want to put 3. You don't want to put 3 and then 6. You'll just get NAM. You want to put 3 and then 7, which you'll get the full name. So let me just expand that a little bit further. So in this string here, M has an index of 0, Y1, then 2, then 3. So this makes sense that you want to start this kind of subset at 3, colon, and then you want to put the end index. But if you go 3, 4, 5, 6, if you put this 6 here, it's not going to actually include that letter. So you got to put in the 7 because it's going to include that first index, but not the last one. So this brings us to the difference between length and kind of indexing. So length is what we would colloquially call, like, I mean, how long a word is. So this word's kind of 4 letters. So if I put 3 and then just added 4 to that, it would have worked. I would have gotten 7. But if here's a new function you guys can start using. So it's called len, it's length. Open parentheses, and then if you put a string that you want to work with here, it's actually going to print out the length of it. So this length is 16, even though my name is Grant, this string. This T is at the 15th index. So this is just something to keep in mind. If you're having troubles subsetting certain strings and you're not getting, like, you're getting 1 letter off, just know that you might have to add 1 or 2 other indices in there just to make sure you get everything you want. So what's nice is that we don't only have two ways to access strings. So not only, put an index or put an index colon and then another index to get a subset, but we can actually grab all of something in the beginning or all of something at the end. So let's say for my string, let's grab that string from above. If I want to grab the name Grant, then all I have to do is grab this G here, which is at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then do a colon. And what this is going to do is start at 11 and then just go until the end. So Python knows that if you put nothing after that colon, it's just going to grab everything until the end of the string. Similarly, if I want to grab just my, I can put a 0, 1, 3 here, and then actually 2 here, and then I'm going to get all of mine. So what's and this still works with the end index isn't included. So I had to put to get my, not 0, 1. That doesn't work, but instead 0, 2. Yeah. So how Jupyter Notebook works is that. So this is a Jupyter Notebook thing. This is not or just like a kind of Python terminal thing. If I just like put here a variable and I press go, it's going to actually print out that variable. So let's do that again. If I just put out the variable here, it's just going to print it out. But this won't work if I put other variables in. So let's say I have string 2 is just like ASDF, let's say, and then I go string 2 and then string. It's only going to print out the last one. So yeah, it's good to put in print. So they make sure, like, if you do want both of these printed, they will both be printed. So I'll do that, print. And then print. See, now both are printed. But if I'm just quickly typing out something for you guys, I might just shorthand and just write string. And then if I can type things correctly and then have it printed out. Yeah. Okay. So here's a little practice that we can do. So if I want to get that B from a sequence A, B, C, D, E, F, this is, remember, 0, the strings are from 0, and then this is at 1, so I'm just going to go like this, get the B. To get the E is at 0, 1, 2, 3, 4, so I'm going to put a 4 in there for subsequence, and I'm going to get it, etc. So I'll let you guys do this by yourself. It's pretty straightforward. Just remember with these guys, when you're trying to get a subset like ABC, it's actually 2 ways to do it. Remember, you can do the way where you can just put in 2 numbers. So you can have, a number colon a number, or you can just do the method where you have 1 number. So I'm going to leave you guys to do these practices. But if you're having trouble with that, please post in the Stack Overflow. I have a little bit to do today. Okay, so that's just a kind of a brief thing about strings. Some people will work with strings and just forget that they're actually kind of sequential and you can access them that way, but it's good to know. But lists are going to be super important. So let's continue on to that. Okay, so lists are another kind of sequential data type where, like, each element can be accessed through an index, just like we saw with strings. But this time, every element in this data type isn't going to be a character. It can be really anything. So you can have a simple string, or sorry, a simple list like this, 1, 2, 3, 4, 5, where every element in the list is an integer, and they're indexed just like how we saw before. But you can also have one where there's just kind of any different data type you can think of inside of the elements of the list. So for this one, we have an integer, a character, or just a string with 1 letter, and then this is the fourth element here. It's actually a list itself. So you can nest lists, and this is what we call it, kind of multi-dimensional lists. Because technically, let's say you have a list in every one of these elements, then you have what is kind of like a 2x4 array. So it's just good to keep in mind you can put anything in there. So they're super versatile for wanting to just kind of put a sequence in things. We'll get to some examples. This could be a list of names, a list of emails, a list of scores, and things like that. But you can also have it mixed and have a bunch of different things. Okay, so let's continue on. So there's a lot of So lists is, I think, our first kind of introduction to like an object in Python, where we have a lot of different operations that are actually built in. So what you can do if you want to figure out just some built-in functions that you can do with lists inside of Python, if you just go help and then put in just a list, or let's say you have, and we'll get to understanding how to make a list in a minute. If you have an empty list or just any kind of list, so let's make any kind of list there, and you go help and then pass in that object, you're going to be told exactly in your terminal directly the things that you can do with it. This might be a little bit intimidating. So if you want, you can always go to the internet browser and just go Python list. And then one of the first hits is going to be the official Python documentation on lists. So this might also be a really good way for you to just see different things you can do. And we'll go through a lot of these different functions today. So you'll get familiarized with it. Okay, so let's just first talk about creating lists. So creating lists, there's two main ways. First, you can just kind of directly create them. So what you do is you put, let's do it a little bit slower. You start with the square brackets, and you put each and every element that you want in your list and separate it by columns. So this is super easy like that, and you can create a list. You can see I ran it, didn't get an error. And let's just put it over there. See, I can put either X because that's the last variable I can go print if you want me to. And you can see we get our list. So this is something actually really interesting. You can put an extra comma here and it still runs fine. So by the way, this is pretty much throughout all of Python. That it lets you, it gives you a little bit of freedom. No, you don't. But so Python is kind of built on the being readable kind of fundamental aspect. So the question was, do you need to include spaces when you're assigning lists? You don't. But like, it's good to put them in so you can actually read it. You can even put in like even more space and it still works fine. This works mostly well with, we'll see dictionaries later, because it's usually kind of long data you're putting in there, long form data. But for something like this, we can just kind of simply put in spaces. Okay, and so if you're not familiar, there's also a function called type. This works for any different thing in Python. You pass it a variable, it'll tell you its type. You can see this is a list. Yeah, okay. So you can also instantiate empty lists. So put that out. You can see there's nothing in there. We'll talk about that a little bit more later. Because what you can do with this is for loops, and just keep adding things onto it if you don't know how much data you actually want to be inputting into your list. And like I said before, you can also make lists within lists. So here's that list where you have an integer, kind of a string, and then another list right there. So I would just ask to repeat about about the comma thing. So the comma thing is that at the end of your list, so let's just make this a little bit more simple. If you add an extra comma, nothing breaks. You can have this extra comma there. This is actually kind of helpful, because if you're always inputting more and more data into a list at the top of a file, let's say, you can just keep a comma there, and then you can always just, type in stuff. So this won't cause an error. That's the whole story with the comma. Yeah, so we're going to get that right down here, how to access it, modify. Okay, so let's just talk about multi-dimensional lists for 1 minute. So I can have lists within lists. So if I have this, you can see that this works out fine. And we're going to learn how to access this kind of nested list in 1 minute. Okay, so let's talk about kind of assessing and modifying. So let's say that I'm working with a list of students. So let me copy that. Students are Brendan, May, Wally, and Stephen. So here is students. Here's the list we're going to play with. And if I want to access the May, so May is the second element in the list, and lists start at index 0. So you can go 0, 1, and then 1 is May. So I can go students 1, just like we did with strings. We can also do we can also go backwards in our indexing. So this is actually pretty useful. So let's say you don't even know the length of your list, but you want to get the, you want the last element in the list. You could do -1, and that's actually going to give you that last element. Thing is, if you don't know how long you should actually know how long your lists are in general, because if you put it in an index that's too big for what you actually have. So I only have 0, 1, 2, and 3 here. If I put in 9, I'm going to get thrown an error. So this is pretty important. Okay, and just like strings, we can also do subsets. So let's say I want to get Brendan and May. I can go 0 to 2, and I'll get both of them. And the previous things that we talked about before with just leaving one out also works. So if I just go :2, I'll get 2 and then everything before that. And similarly, if I go 2 and then colon there, I'll get Wally and Stephen, everything including 2 and then afterwards. Yeah. So what other things we can, okay, so these are some more list specific ways you can access the data. So if I wanted to get, so if I go :2, this will actually give me every other item. So this is pretty interesting. This means that I start at 0, count up 1, 2, also print that out, and then this will go into the end of the list itself. So if I add in some more elements here, you might be able to see this a little bit easier. So if I go :2, it's going to start at 0 actually. Go print out 0, go 2 more, print out Wally, go 2 more, print out 4, and so on. So this might be good if you need to go like everything odd in a list or everything even, like even indices in a list or odd indices in a list. This will help out that way. And then what you can also do is you can start that every other subsetting from any indices you want. So when I just have no number at the beginning of like no number :2, it's gonna default at 0. If I put in 1, it's gonna default at May because she's index 1, and then go on from that. So you can see 1 is May, and then I said I want every other element being 2. So it goes 1, 2, gets Stephen, 1, 2, gets 5, and so on like that. Yeah, so yeah, this is actually important too. So when I'm subsetting lists like this, so any list you want. So let's actually just go 1 to 2. So even though 1 to 2, remember what this does is it starts at 1 right here, and then subsets. So this is a little bit more complicated example. Let's just start do that. So if I do 1 to 3, I'm going to get May and Wally. And if I look at the type of this, we'll see that this type is actually a list in itself. So this is something that is going to be important. When you access a single element of a list, you're going to get, so this is a single element of a list, you're going to get a string. But if you subset your list, you're going to get a list. So here I say print type string and then just a single index to get May. She's a string. But if I subset the list, it's going to be a list in itself. So this might be important if you're doing any kind of testing in your code to make sure that things are working properly, and you set up some kind of statements that make sure that things are getting lists or things are getting strings. This might be something you have to keep in mind. But okay, what else can we do? Oh yeah, so here's the last one we'll kind of touch on with this right away. So if I do ::(-1), what will happen then? So -1, remember, goes starts from the last element. So when you do this, actually, you reverse the list. So let me take out that type statement right there, so things are cleaner. Oh, not string, but we want students. And let me also take this out. So this will actually reverse the list. So this might be easy or important if, I don't know, let's say our list is alphabetically ordered. You want it reverse, do it like this. But we'll see a way to do that too in just a minute. So that's kind of basic accessing data that's in your list. It's indexed, just like how we were seeing with strings. You can slice in your list. So that's when you give it kind of an index, colon an index. But yeah, okay. So lists are mutable. So what I mean by mutable is that you can actually update lists, unlike strings. So if I had a string that was like, you know, what we saw before, my name is Grant, and then I went string 1, we get that first letter. But if I try and change that first letter to something else, it's going to throw me an error. So when something's immutable, you can think about that right now as like it can't be edited. So it just is the way it is. But elements of a list are different. You can update them, which makes sense because, I mean, our students might not only be these 4. You might add more later. So if I want to add a new, if I want to change, let's say May wants to change the spelling of her name, I can go students 1 to access that that element, and then I can put an equal sign, and then the name, the way she wants to change it. Let's say she's changed the spelling of her name, and then let's print that out. You can see that I have May actually changed her name there, and we can also do this with slices. So let's say May and Wally both want to change their name. Then what I can do is I can first get that slice. So if you remember, this slice here will get me May and Wally, and I can actually put an equals and then pass in their new spellings of their names like that. And then let's just print students. And you can see that their names there are changed. So we'll talk a little bit about this right now. So I am just accessing this element by what we kind of saw before with that slicing. And then I need to pass in a list actually with their new spellings of their names. And then that will end up being updated in the list down here. So a quick note about this, if I go ID, just take this snippet above. So the ID function, what this will do is every variable in Python actually has a unique ID associated with it. So if I do ID and then a variable, it's going to print out a number that is going to be kept with that variable if that variable is the same kind of throughout everything. So how about we check to see if this is the exact same string, and it is. So we can see here that no matter the fact that May and Wally's name kind of changed because I accessed those elements and then changed the name, the value that ID gives us is the same. So you're actually editing the exact same string. Because I mean, if you had an immutable data type like a string, you could always copy that string and then change a little from there. But for strings, you're actually editing the exact variable itself. So if you go up here in that variable editor, you'll see that, I mean, students there is changed. If you kind of update data in there, that this variable itself will change. Okay. Let's continue on. Okay, so membership. So membership is a general concept about, let's say you have a kind of a data type, it could be like a spreadsheet or a list like we have here, whatever you got. And you want to see if something is inside of that. Let's say that you wanted to like make sure to see if Brendan is in your students list. So I don't know, maybe the students list is something that comes out. Yeah, so membership. So if you say, so yeah, let's say this list of students comes out from a program that you have that kind of tells you who's enrolled in the class, and maybe this is a very long list so that you can't actually kind of just parse it to see that you have 4 students here, and you want to test to see if you have if an element exists in that list. You can use this in. This is called a logical check because what we'll be getting is either a true or a false. So let's do that here. So let's just print Brendan in students. And as you probably expect, it's going to be true because you in fact have that. Now, I mean, this is case sensitive, character sensitive. If you change the spelling of Brendan's name, it's going to do false because it's looking for that exact, if that exact element is actually inside of the list itself. So if I change this instead to a name that isn't in, I mean, as you expect, it's just going to give you false. And so you can also use not, so not in. If we'll kind of negate that in, just like we probably saw before. And you can see this is true because there is no name in the list right now that is Roxanne. Okay, so let's keep going down. Okay, so from now on, we up until this point, we've been talking about like we know all of the data inside of the list and where it is because we can quickly look at the list. But like I had said before, if this list of students is very long, we might not be able to quickly figure out like, you know, May is index 1, Wally is index 2, etc. And we want a kind of a programmatic way to figure that out. So if I have this students list right here, and I do students.index, and then I pass in what I want to search for. Let's say I'm searching for May. It's actually going to give me the index of where May is. So this is super useful actually, because if I didn't know exactly where this was, then I can save that. So let's just save this as the index equals students.index May and have that saved in a variable. And I can actually pass that to students, just like we were doing with directly inputting numerals before, and get May out of there. So this is a really good way of figuring out where something is, and then you can reuse that index later if you want. So if you want to, let's say, update May's name and you don't know exactly the index where it is, you can first find that index and then, you know, reassign her name like that. And then if we want to, let's print that out now. You can see that we have successfully updated a name. So let's just talk about this a little bit further so it's completely understandable. If we can use this list.index and this will return where in the string, or sorry, where in the list this string is here. So this is going to evaluate to 1. And then we pass that as the index for the students list. And then we're going to reassign that to this new spelling. And if we print it, it's lo and behold changed in the proper location. And you know, we could have done this perfectly the same if we had that list. And this is what we did exactly before. We did students 1 equals May. And then I print students. And it works up here too. But this top way is if we don't exactly know the index it is. Yeah, so this is the whole point. You don't have to know the index. Yeah. So this is exactly what we're doing here, Marco. We're searching this list for May, and then saving the index where we find her, and then putting that in, passing that to students, and then access that element, and then changing that element to May. Okay. Let's move on a little bit more. Oh yeah, okay. So Mark's asking, what if there are 2 entries and you want to index out the second? So 2 entries. So let's see what that looks like. So if you're we'll just cover index and then putting a single kind of argument in there. But something to note if you have multiple elements that have the same value, like May and May, and you pass and you do index, it's only going to give you the first one. So that's something to keep in mind. Okay, let's continue on. So lists, adding and removing. So if you have a list, obviously you want to not just have it static. You're going to want to add more elements to it or subtract it. So this is pretty easy. And this is what and we'll talk a little bit about empty lists too when it comes here. So let's say there's a new student we want to add, his name's Norman. So we go students.append. So append is the function you want to use when you're going to add in new elements to a list. So we're going to go students.append Norman, print out students, And you'll see here that Norman is now added onto the end of that list. But if we do pass it two names, that's not actually going to work. So if we want to pass in, so this will only work if we want to add in one element onto the end of a list. If you want to add in two different things, there's actually a separate command. So the separate command is called extend. So extend, you actually need to pass in a list for it to work. So let's say I want to add in Tate and Lisa and extend it onto this list of students. If I use the extend command and then give a list containing those two names, it's going to be properly appended. So if you forget this extend and you instead write append, you can see what actually happens is that you appended a list inside of that list. So extend is what you do to fix that. You actually then unpack this list that you're passing extend, and then it's being added. So let's compare those two here. So if I append this list containing Tate and Lisa, let's print out students, and then right below it, let's instead use extend. And let's also redo the list right there. So you can see in the first one when I simply did append, it appended what you gave it, and you gave it a list, so it appended a list. But if you instead say extend and pass it that same list, it'll unpack the list and put it as elements in that original list right there. Okay, so let's continue to removing. Okay, so removing. Let's say I still have that list of students. If I do students.pop, this is actually a way to remove things. I know it might seem unrelated to removing, but it's how you can remove items. So if I do students.pop and then print students, you'll see that this removes the last element. So this actually removes Stephen because he's the last element. So you can also pass give pop an index. So if I go 0, 1, 2, 3, Stephen's at index 3. If I give it pop 3, it'll still remove Stephen. So that works the same. But instead, if I wanted to remove Brendan's name and I passed it 0, which is the index of Brendan, then there you get May, Wally, and Stephen. Then Brendan is going to be removed. So this also, remember, this makes you know where, this requires you know where every name you want to remove is. So if we wanted to use something we learned in the previous parts of this class, the .index command. So let's say we want to remove Brendan, but we don't know where Brendan is in the list. We can go students.index, pass it Brendan, and then save this as, like, let's say index Brendan. Take this index and then pass it over to pop. It's going to work out. You're going to remove Brendan. So line by line, we're kind of instantiating that list. We're finding the index that Brendan is at using the students.index function and then giving it Brendan what we want to search for. We're saving this, which is going to come out as 1 or 0. Sorry, this is going to value it as 0 into index Brendan, and then we can pass that on to the students.pop command to actually then remove him. So if I just call this index itself and put other names, we can see that if I put in May, we remove May. If I put in Wally, remove, oh, give me 1 minute. If I put in Wally, then it's going to remove Wally. Put in May, it'll remove May, etc. So this is super useful. Okay, so let's keep going down. Okay, so in place operations. So we've been using a few these functions where we do kind of students.pop or students.append or students.extends. And you can notice that here we're not doing something like students equals students.append. We're just calling that function. So this is called an in-place operations because it changes the list that we called it from. So let's just analyze this right here. So this is kind of a long example, but we'll go through line by line. First, we're creating a list. So this just has a bunch of numbers. And then we're gonna print out that list and this unique identifier for it. And then we're gonna run two different functions on it, okay? We're gonna run this function called sorted and this function that is just called x.sort. And we're gonna look at this. There we go. So so the original data is printed out here, and then .sort and sorted sorts the data, but does it in two different ways. Both are going to return in ascending order the list elements, so it's going to rearrange the list elements, changing their index, of course. The one here was originally 0, 1, 2, 3, 4, but now is index 0 in this new list that we made. But it does it in two different ways. So you can see that the ID for the original data and the ID for the data sorted by x.sort, it's the same. That's because x.sort is this kind of in-place method. It's a method, it's a function that actually modifies the data itself that it's called from, but sorted, and then you pass it that x, creates a whole new variable that we stored in y and we printed. And you can see that it's a whole nother variable because it in fact has this different ID. So sometimes there are two different two different functions. They can do the same thing, but one's in place, one's not. It's good to keep in mind. And just be careful. Like, we have this x, x.append. If we put in another number, this appends that list itself. This will come more of a problem when you're working with kind of more advanced data types and things where you need to be pretty certain before you run something if it's in place or not. But this is important to know. And if we use that help command, so reverse is another in-place function. So if you ever don't know, you can go kind of your variable, which is a list, .reverse, and it will print out the help, the kind of documentation for that function, and it will explicitly kind of tell you because it's a big deal if it is or not. And if you don't really have a list like x that is already instantiated, if you just write list.reverse, it'll do the same thing. Okay. So let's continue on. So that's most of what kind of introductory things about lists you need to know. But they're not the only data type that you can actually work with. So tuples are another kind of data type. They're pretty similar to lists in the fact that how they look, I guess, are similar, but they function very differently. So you can see that I'm creating a tuple down here. The tuple is John Doe 78. So this could be, something like a function returns someone's first name, someone's last name, and then their age. Let's say John Doe is 78 years old. You can see that this looks pretty similar to lists. It is a sequential data type that can take any different kind of variable. So we have two strings, and then we have an integer. But you can see that this data type is created by using smooth parentheses. Or you could also use the tuple command to make it. So down here, you can see tuple, open parentheses, and then you type in each element with commas between them, and you can also make your tuple that way. So tuples are the same because you can access them the same. So let's just go through this really quickly. So let's say I make my tuple John Doe 78 like that, print it out. There it is. I can go 0, get John. I can do 1, get Doe, and so on. But they're immutable. So this is the key difference between lists and tuples. So if I try and update John's name, so let's update John. So T of 0 is John, right? If I want to make it Joe Doe, and I try and do that, it's going to give me an error. So it says tuple object does not support item assignment. So this is because tuples are in fact immutable. They're not mutable like lists. You can't update entries in there. So this, you might be wondering, like, why would you ever use something that's as inflexible as a tuple? Well, it's actually, there's a lot of reasons why, but one reason might be because of performance. So you have to load all your kind of lists into memory when you want to update them, because since they can be kind of so malleable, the computer needs to do that to figure out how big it is before it then adds more things to it. But for tuples, since when you define them, you can actually add more elements or change elements inside of it. So you also can't go t.append. That just doesn't exist for tuples, won't work. Because they're of a known size, They're just, they have this known memory requirement, and it can improve how your faster function works. So this is mostly a performance thing. And also could be like, you just want to make sure that you're not appending things willy-nilly in your program. You might want to use tuples instead. Okay. So yeah, there's two ways, of course. You can just, like we did before with lists, but instead of using the square brackets, we just use smooth parentheses. And then you can also use this tuple command like that. And sorry, this is actually a problem in the lecture here. When you call the tuple command, you actually have to pass it a list, believe it or not, of your different elements. So if I wanted to create a tuple using the tuple command, you open your parentheses and then give it a list of the elements you want in that tuple. So let's print out the T like that. And then there you go. Your tuple is created. And you can see that when I print it out, we got those smooth parentheses. So that is, in fact, a tuple. But the easiest way is just to kind of make them without the command itself. But doing this might be more explicit, and it might be something that you wanna do just because, so you know. Yeah, you can totally make a list into a tuple. So let's make this as like my list equals to, with square parentheses, square brackets, John Doe 78, and let's print that list. Okay, so see it's a list. And I can make, so this is actually why, one reason why this tuple command exists, because if you have a list and you want to make it into a tuple, you can do it really easily by just then going my tuple equals to tuple and then passing in the list. So this is already a list, so this will work out fine. And then let's print out my tuple. And there you go. So yeah, that's a reason why this exists this way. It's because it helps you with that. Okay. Right. So we talked. We touched on this in a minute about what immutable means and why this is important. So you can't actually change this tuple John to Jane here because you can't access the data. It just doesn't work that way. And it's important to remember that you can actually have a bunch of different kinds of data types in tuples. So I know I got the question before, if do I really have to put the spaces between parentheses? You don't have to, but you can do spaces and you can do more than spaces. So here I'm separating out with commas every element of this tuple that has a first and last name that's inside of a list, that aged, and then another tuple that is their email address, and then their current employment status. This John Doe is apparently retired. He's old enough to be so. So let's look at this example just a little bit more. So this is a tuple with 3 elements. So if I go length T, you're gonna see it's 3. So there's 3 elements in here. The first element is a list, John Doe, which has two elements in there. If I wanted to get that first name, I would, from this tuple, so this tuple is long, right? I would first have to access the list where the first name is. And then this is just a simple list. So if I go type list, you'll see that I am telling the truth, that this is a list here, it's a list. I can directly access the list from a tuple. So if I open another square brackets and I put a 0 there, you'll see I'll get John. And that's because when let's make these into print statements so I can print 2 things at a time. If I go T0, T0 gives me that list, and then I can directly access that right off the bat by putting in just another square bracket and then opening it there. And let's say I want to get the email. So the email is of the 0, 1, 2, that third element or the second indexed part of this tuple. So T2 gives me that, and I can access the email in a very similar way by then just getting that first 0 index from the tuple here. Okay, so let's just continue on. So this is like one way to store your data, but this is not really that intuitive, right? Like you have the first and the last name as the first element, you have your age as the second element, and then you have the email and like their kind of employment status as a tuple in the third element, but this is very convoluted. What if you had a way to like kind of label each and every element in here? That brings us to dictionaries. So dictionaries are incredibly useful. They are very much similar to lists, but instead of having data sequentially by index, you have data sequentially by keys. So every single kind of value inside of a dictionary has a unique key attached to it. So for example, our genetic code, if you want the values to be those different amino acids or like the stop codons or things like that, you can assign keys to get this data, and these keys can be anything. But here we have them as strings, as the different codons. And while keys have to be unique, values can be repeated. So inside of the genetic code, we have multiple stop codons. So you could have multiple elements of this dictionary, and you can have them all have the value of repeated stop, but you would just have to have the codon to be different. Yeah, Lily's right on that. Yeah, so you'll hear people talk about key value pairs a lot, or an item. So these are kind of synonyms. Key value pair is just each element of a dictionary. So this is its key, and then its respective value. That's a key value pair, or also called an item. And yeah, so you can really store pretty much anything inside of that value part of the dictionary. You can have it as a string, so you can access something like an email. An email is going to be inside of a string, so you can use that as a key for user data. Or a gene ID, if this is just a bunch of numbers, then you can have it as this will just be a bunch of this will just be an integer to access the gene sequence that you're looking for. So security number is going to just be numbers, that could be a key, etc. Let's look at some examples. So here we have elements where the full long name of the element is accessed by using just the short code that we see on the periodic table. So H to hydrogen, Li to lithium, etc. Or here we have just characters, just one element strings referencing each other, etc. So let's look at this example. So if we have this long dictionary here. So this dictionary is, let's say that we're creating like, I don't know, a contacts app on a phone, and we're going to be storing each and every contact as a dictionary. That contact probably has, a name, a surname, and then their contact info, and that's how we're going to store it. This is the data type that we figured out beforehand. I have not changed the name, so let's make this a little bit more accurate. So I did not change John and Grisham, but I did change the emails before I upload this to GitHub. So you can change it along with me to make more sense. So I had John Grisham and then the email being becky@gmail.com. That doesn't work. So I'll make it to Becky and then Chambers. Great. So here's the dictionary we're going to look at right now. So if I print it out, it's really it's just it prints out pretty ugly. We'll get onto how you can print things out better later. But if I was just given this dictionary, we can do .keys, and we can figure out the different keys in here. So you can see that these are name, surname, and contact. Okay, so we know exactly those keys that we have: name, surname, and contact. We can actually access the data like that. So this is pretty similar to lists before, but I had given it a list, an index. But for dictionaries, we give it the key names. So if I pass person with the square brackets name, it's going to give me Becky. If I pass with the square bracket surname, it's going to be Chambers. And if I go contact, you'll see that it actually gives me a dictionary. So this is interesting. So let's print this out. Print. And then print out the type of this here. See, so I have this dictionary, which is their phone and then their email. I have it saved as an element or an item in this dictionary with the key contact. And I can keep going too. So if I want to look at their phone number, I'm going to have to access not only contact, but also the phone key within that dictionary. And then let's print it, and then let's see what happens there. So you can see I have another dictionary in there. If I wanted to get the office, then I'd have to continue on. This is all just nested data, and then put office, and then I get the number, the actual phone number itself. And if I want to get the cell, likewise. Now, let's say I want to get this email here. So you can see that if I go email, let's just cut this off right now. It's going to print out what actually looks like a list. So here is an example of a dictionary within a dictionary that has then a list, a list within a dictionary within a dictionary. So I first access contact to actually get this dictionary right there. And then if I want to get this first email here, since this is a list, I got to pass it a 0. And then I get the email. So this is a more organized way to hold data. So remember up here, we had this example with John Doe, their age, and then the email and their occupation status. This is kind of unorganized, and you really have to know beforehand where all the data is. But this is an easy way to kind of make and share data between your programs, or maybe you're creating API and you print this out to give to someone. This is just kind of important and much neater. Okay, so let's continue on. And yeah, so by the way, if I want so email right here is just a list, but this could very well be, a dictionary where this is labeled as personal as the key, and then this is labeled as like work email as a key. Like you could also do that. Just like lists before, if I use the help command, you can see there's just a bunch of different built-in functions to create, to access keys, to modify the different items, et cetera, et cetera, et cetera. And we'll go through a little of them here. But okay, so how do you actually create a dictionary? So it might have been a little bit obvious before. So you can do just kind of a direct statement. So this is what we've been using for a while now. So dict-x. So you could just put your key colon the value, and then have just a comma separated kind of list of these like this. So we can also add on then C, and then a number. There you go. So you can also use the dict command. So just like we had for tuples, if you go dict, and then open parentheses like that, we can add in pairs like this. There we go. Use one, etc. And this is another way of creating a dictionary where we use the dict function and then pass in a comma separated inputs where you have your key equals and then your value. So just two different ways to do it. It depends on your situation, which one's better. Okay, so so this is important. So iterating over a dictionary. So we've talked about it in the past, how to do for loops, while loops, and things like that. And so let's just do a quick refresher on that. If I write a for loop like for I in, and then let's pass it a list like 2, 4, 5, and then print I. So here this is a quick refresher. I'm doing a for loop where I'm printing every element of this list. You can see I print out every element. But remember, dictionaries have key value pairs. So you have to, oh, we have not covered loops yet. Do we know how to do any of this? Okay, so this is gonna be important for later. LOL. I did not double check to make sure we didn't cover this or not. So, okay, we'll be covering this on Thursday then. It's gonna be Tobias's, Toby's lecture. But yeah, so there's obviously, you'll see it on Thursday, but there's different ways that we can actually iterate over lists because key value pair is not just iterative. We'll see. Okay, so that brings us over to membership. Okay, so let's say we have a contact here the contact is first name, last name, and then occupation. Let's print it out. So this is the dictionary. We can do something really similar that we did in lists to see if we have a key actually existing in there. So let's do that here, contact. So if we go email in contact and then print that out, you'll see it's false because we don't have a key called email inside of the contact. But if we put first name, it's going to evaluate as true because we do have that as a key. So you can do similar kind of membership tests that we did in lists, but we can do actually in keys. But what about like the values and things like that? So we were going to cover that through the lens of for loops, but since we're not doing for loops, let's cover some of these functions, these built-in functions that I kind of hinted about over here with the different operations we can do. Let's try and do some membership tests about Stephen. So let's say I have this contact and I want to see if Stephen's inside of this if this is Stephen's contact itself. Well, if I try and do Stephen in contacts, it's not going to work because if you remember, just doing this, if I'm doing kind of element in contact, it's going to look through the list it's going to look through the keys. So if I go first name in contact, it's going to go it's going to say true, but if I go Stephen in contact, it's going to be false because this is looking through the keys. But what we can actually do is we can go dot values. And then this will actually look through the values of a dictionary. So let's look about this a little bit further. So let's make a new cell here. So if I print out contact.keys, so let's just start with contact.values, you'll see that we get a, what's called a lazy object. We get this dict values object that is actually kind of printing out every single value we have inside of this dictionary. We can actually do the same with keys too. So let's print that out, dot keys. So we can also access just all the keys of a dictionary like that. And there's actually a third one. So we can print out the items. So items will print out every kind of key value pair that we have in the dictionary. Now this items is going to become important on Thursday when you look about for loops. So let's just ignore that one for now. But keys and values are important at the immediate moment because it allows us to do membership checks in either or. So Python is about being really explicit. So if I do print Stephen in contact.keys, it's good, or let's do first name. It's going to return true because first name is a key in contact, but it's also going to be true if I just kind of say in contact. That's because when the default Python chooses for doing this kind of in command is it looks at the keys. This might be better for you to do in general, just because Python's about being a little bit kind of more descriptive. So just if you have a choice, default to this. Don't. It might be better not to do this right off the bat. But yes, okay. So let's continue on. So modification. Okay, so keys are unique. We can actually use them to update data within a dictionary. So let's just use this really simple dictionary with name in it being John. If we want to change this this John value to Joe, we can actually go to contact. Sorry, I press return too quickly. Contact name, and if I print this out, you can see that this is accessing John, like we learned before. John, and if I want to update this here, so contact name, we can just do kind of what we did with lists before, where we did kind of list and then put in an index equals a new value. For dictionaries, we can do the dictionary and then the key that we want to edit, and then pass it a new value. And you can see now it's printing Joe. And if we print the whole kind of dictionary, you can see that the whole dictionary has that John value changed over to Joe. We can also add in kind of a new key value pairs this way. So let's say that we want to add in his email being joe@joe.com, and we also want to add in his salary. So let's go salary, and he's gonna make a bunch of money. Wouldn't that be nice? And then print that out. So this is so to just add in new key value pairs to a dictionary, you can just you can just do it this way. It might be strange because it seems like we're accessing email, but we haven't put email as a key yet, but it still works. Just give it that new key that you want to have it added in, and then tell it what value you want, and then you're going to have it reflected down there. But it would be nice to add in all of the add in the email and the salary without having to do it in 2 lines. So let's say I actually had another dictionary called like new info that had key value pair email and it being joe@joe.com, and then also salary, and that being a very, very large salary. And I wanted to do the same thing I did here, but just a little bit quicker. You can use this update command. So you can do contact.update and then pass in the info you want to add to it in the form of a dictionary, and it will do the exact same thing. This is similar to the extend command that we saw with lists and is an in-place operation. So keep this in mind when you want to kind of add more things onto a dictionary. Okay. So you might have noticed this during the lecture, but it's kind of ugly printing out dictionaries, because it just kind of gives you this comma separated display here. You got to kind of squint and see. If you have a lot of things like before, you can't really parse it easily. So something called pretty printing can be used to print things out really cleanly. So this is a external library that has to be imported. And I don't think we have covered imports and exports yet. So if you want to use this, you just want to more or less, if you don't understand what every line is doing, just copy it directly from here and just replace the variables you want to print. But we'll be covering imports, exports later. So if I import, what I want to do is I want to import pretty print, and then you do prettyprint.prettyprint like that, and then pass it a dictionary. So we'll use this dictionary right here. So let me instantiate that above. So this is a mess, right? So let's briefly just see how much of a mess this is. So print.dict. Yeah, I can't really parse that, but I can parse that with using pretty print. So let's go back to how we do that. So you go import pretty print, and then you go prettyprint.prettyprint, and then you just pass in that dictionary, and it just prints it out really, really nicer, more nicely, if you will. But yeah, this might be a good thing to keep in mind when we get through the importing module section, because then you can just do this with your code and just have it in there as your import statement on top. Okay, you can also, this is a little bit more complicated, but you can do just change like different kind of spacing. So let's just briefly see how that works. So this is an FYI for later when we talk about imports, but you can also kind of customize this. So this now has an indent of 4 spaces, and before it didn't actually show that. So there's a lot of stuff you can play with pretty print. Okay, we're going to end off today with talking about assert statements because it's in your homework. You might have been like kind of questioning what it is, but this is just a brief kind of explanation of what they are, so that you are not totally confused by what you're seeing in the homework. So assert statements are something that helps to make sure, kind of tell you that your code is working the way it should be. So let's say that I have some kind of program that gives me a score, and I need to make sure that that score is above 0, is a positive number, or something is going to break. I can use assert statements to kind of make to tell me when that is not happening, when I have a score that is below 0. So let's do an example. Let's say I have a score and I got it from somewhere it's 20. I want to make an assert statement. I want to make sure that is positive. If I run this code block right here, nothing bad is going to happen. But the moment I kind of break what's in that assert statement here, so I put my score as -20, and then I'm still asserting that same thing, that I want scores to be positive, it's going to throw me an error. It's an assertion error, and right now you can see it's actually empty. I can customize that statement by just going comma, custom error statement, and you can see that it prints out custom error statement on there. So let's make this a little bit more informative. Please use only positive scores. So this might be a way that in a really large unwieldy program you're writing, to kind of quickly test to make sure everything's working the way it is. There's better canonical uses for this that we'll learn about later, but this is what's happening in the homework right now. So yeah, so in the homework, you'll see it kind of in this form. So this is pulled directly from an assignment. Let's just quickly look at it. So in this assignment, you were trying to test your knowledge to see if you could add 2 numbers together in Python. You first want to put your number 1 and number 2. You're supposed to add in what you wanted that to be. So I made number 1 6 and number 2 2. And then the correct way to do this is going number 1 plus number 2, and then running it. Nothing wrong happens. So this presumably teaches the kind of checks to make sure you know how to add 2 numbers. But let's say that instead I put in minus sign instead of a positive sign. It's going to break. So let's just look at the assert statement here and how it works. So this assert statement, you had, it's checking to make sure that this equals number 1 and number 2. So we covered Boolean operators. This equals is make sure that these will result to the same thing. So if you didn't actually put in this plus properly, it would fail like we saw before with putting in a minus. But if we do put in the plus properly, it works. So this is those weird assert statements that, there was the big wording, don't mess with below for checking, or whatever was on your assignment, because it was important for just to not mess with that, so you make sure you're getting it right. So something to notice is that assert statements don't check that you actually did number 1 plus number 2. All the assert statement is checking is that the result addition, this here, equals number 1 plus number 2. So I very well could just have written an 8, and I wouldn't have gotten an A on this assignment. But yeah, it just checks for kind of a Boolean statement, this equality. It doesn't actually check to make sure that you did number 1 plus number 2. That's something to keep in mind. Okay. Great. So with that, this is everything we covered in the lecture. If you have questions, feel free to put them in chat. So, okay, I have one question. Let's go over. So what does dot format do after the assertion? Okay, so you remember how we had up here, I was saying that if this is false, right? So I have this -20. It's going to throw an error, and it's going to, and if I had nothing there, the error would be empty. But I can do comma and then type in a string. So example string. That's gonna become the error message when the assert statement, when this is evaluated as false, because you can see score up here is -20. So what's that format doing? So the format out here is actually a way that you can, what's called like concatenating strings. It's just making strings from other strings. So let's play with just another cell block down here. If I have so the simplest way to concatenate strings is just to plus them. So if I have a string a plus b, and then I want to print string, you can see that it's AB. But this is just a little bit more complex of a way to format strings. So if I instead I open my string and then put in 2 sets of closed curly brackets, then did dot format. So now what I need to do is I need to pass it 2 different things that it's going to fill in to these curly brackets here. So if I pass an A and then I pass in B, I'm going to get the same thing as just doing A plus B did before. So A plus B, let's print these guys. So A plus B, print, and then print. Both of these will give me this the same result of just AB. But as you can see, so this error statement here, when I got an incorrect answer, so let's say I did number 1 minus number 2, so this is wrong, right? The assert statement is going to be tripped because this evaluates us as false, and then it's going to print out this error statement. So you can see that the error statement dynamically changes to exactly what the error was. So you can see that if I did number 1 times number 2, it's going to say that 12 does not equal 6 plus 2. And that if I do minus, it's going to say that 4 does not equal 6 plus 2. So the 4 and the 12 is changing because I have this kind of format string down here where I have 3 different things I can pass in, and then everything that is not in the curly bracket stays the same. Then I pass in result addition, it goes right there. Number 1, number 2, it goes there and there respectively, and that's how we actually create this. So if I change number 1 and number 2 to, let's say, 9 and like 1, you can see that that also changes with this error statement. So this is just this mark just put in here for the homework, so that if you do get some of these questions wrong, the assert statements will help kind of tell you what's wrong in your code, so you can double check it. So that's a little bit more on strings since I got the question. And yeah, when you're doing the assignment and like you see things like this or like assert statements or like this kind of string formatting that you don't understand, it might kind of trip you up. So that's why I wanted to cover it, I guess, when I got it as a question. But with that I kind of have, that's everything we want to do for the lecture so far. So yeah, thank you so much.